Let's learn about the types of batteries, their charge-discharge characteristics, and key terms. Lithium-based secondary batteries can be divided into lithium-ion, lithium polymer, and lithium iron phosphate. Let's compare lithium-ion and lithium polymer, which are used in portable devices. Lithium-ion batteries have an output voltage of 3.7 volts, which is about 3 times higher than the previously widely used nickel-cadmium 1.2 volts and nickel-metal hydride 1.5 volts. And they also have many advantages such as high energy density, excellent temperature characteristics that can be used between -55 degrees Celsius and 85 degrees Celsius, and a long life cycle. Disadvantages include the possibility of electrolyte leakage and explosion due to the use of liquid electrolyte, and the cell design is limited to a cylindrical shape. Lithium polymer is a battery that uses the most chemically stable polymer electrolyte, that is, a solid or gel-type high molecular polymer, instead of a liquid electrolyte with a risk of explosion, while maintaining the excellent performance of lithium-ion. Since it uses a polymer electrolyte, not only is there no risk of leakage or explosion, but it also has excellent design characteristics, such as being thin at about 3 mm and being able to be manufactured in a small size. However, the manufacturing process is complicated, so the price is relatively high. And the energy density is lower than that of lithium-ion, and the characteristics are poor at low temperatures. In addition, lithium iron phosphate has a long life, is safe, and can be used in large quantities, so it is mainly used in large capacity devices such as industrial equipment, golf cars, and hybrid cars. Looking at the charge characteristic curve for a lithium-ion battery, the red line represents current charging and the blue line represents voltage charging. When the battery is completely discharged and in the 2 to 3 volt range, a pre-charge current of about 1/10 of the normal charging current is applied. This range is called the pre-charge range. And it is also called trickle charge because it slowly charges by sending a small current like dripping water. Since this is the stage of waking up a completely discharged battery, a pre-charge is performed with a small current. When the battery is charged to 3 volts or more, it is judged to be charging stably and switches to rapid charging. This section is called the constant current charging section. In the final stage, when the battery voltage reaches approximately 4.2 volts, it enters the constant voltage charging stage, and the charging current gradually decreases. When the battery voltage reaches 4.2 volts and the charging current does not exceed a certain standard, it is considered to be fully charged. In this way, the charging IC monitors not only the voltage and current status of the battery, but also the temperature, and safely performs optimal charging control suitable for secondary batteries. This is a discharge curve when a lithium-ion battery is discharged. The vertical axis represents the battery voltage and the horizontal axis represents the discharge status. It shows the discharge characteristics, and when the battery's charged capacity is over 80%, the battery voltage is over 4 volts, and the 100% full charge voltage is approximately 4.2 volts. When the battery has about 80% to 20% remaining capacity, the cell voltage remains constant around 3.7 volts for a fairly long time. This voltage that the battery can maintain on average for the longest time is called the rated voltage or nominal voltage. And when the remaining charge falls below 20%, the battery voltage drops rapidly and is completely discharged. Let's learn about the main battery terms. The rated voltage is the voltage that the battery can output for the longest average time, also called the nominal voltage. The typical lithium-ion or polymer is 3.7 volts. Full charge voltage is the voltage when the battery has the most energy, that is, when it is 100% charged, and is basically higher than the rated voltage. Lithium-ion or polymer is 4.2 volts. Milliampere hour is a unit that indicates the capacity of a battery, and it refers to the amount of current that can be used for 1 hour. Here, milliampere refers to the current capacity, and hour refers to 1 hour, so a battery that is marked as 1000 milliampere hour can be used for 1 hour with 1000 milliamperes. In other words, it can be used for 1 hour with a current of 1 ampere. Depending on the current consumption, the battery can be used for 1 hour, 2 hours, or even more. For example, a 1000 mAh battery can be used for 5 hours if a current of 200 milliamperes is consumed. The term discharge rate, C rate, is used in relation to battery charging and discharging. C is an abbreviation for capacity. In other words, 1C means discharging or charging 1 time its capacity. Since the concept of C means battery capacity, it is expressed as how many C charge, not only during discharge but also during charging. For example, 1C charge means that the battery is charged with an amount of current equal to its capacity. In other words, if you charge a 1000 mAh battery at 1C, the charging time will be 1 hour. And if you charge it at 0.5 C, it will take 2 hours. Basically, it is recommended to safely charge at 1 C or less, that is, within the range of 0.5 to 0.7 C. Batteries are connected in series or parallel to increase voltage or current capacity. The terms S, short for series, and P, short for parallel, are used. 1S2P doubles the current capacity by configuring one cell in parallel, and 2S1P doubles the output voltage by configuring one cell in series.